In this video, we are going to see how to expand a binomial using a Pascal's triangle. Okay, first let me construct the Pascal's triangle. So for that, let me write 1 over here. So in the next row, again, I'm writing a 1 and again 1 over here. Okay, now in the next row, again, I start with 1. Now, to get the next term in this row, I'm just adding these two numbers 1 and 1. 1 plus 1 is just 2. That has to be done over here. Then I have to end up this row with 1. Okay, now let me start the next row again with 1. To get the next term, I have to add these two numbers 1 and 2. That is 1 plus 2 is 3. To get the next term, I have to add these two numbers 2 and 1. 2 plus 1 is 3. Again, I have to end up with 1. Okay, now again, I have to start with 1. To get the next term, I have to add these two numbers 1 and 3. That is 4. Now to get the next term, I have to add these two numbers 3 and 3. That is 6. To get the next term, I have to add these two numbers 3 and 1. That is 4. Again, I have to end up with 1. Okay, again, I'll start with 1. To get the next term, I have to add these two numbers. 1 positive 4 is 5. Okay, now we have to add these two numbers. 4 positive 6, that's the next term, that is 10. And to get the next term, I have to add these two numbers, that is 10 again. So to get the next term, I have to add these two numbers, that is 5. Again, I have to end up with 1. Okay, to get the further rows, we have to do the same process. Okay, now I have to consider here, this is 0th row. And the next one is the first row. Let me write the stuff over here. The next one is second row. The next one is third row. The next one is fourth row. The next one is fifth row. Okay, so if you want, you can write even sixth row, like by doing the same process. Okay, now this 0th row means 0 represents the exponent of the binomial. So here first row means this number 1 over here represents the exponent of the binomial. So this second row, this number 2 over here represents the exponent of the binomial. Okay, now let me consider a binomial that is A positive B. So here let's consider this 0 over here. So I'm taking this 0 as the exponent. Anything raised to the power 0 equals to 1. So when I raise this binomial A positive B to the power of 0, it is equal to 1. So that exactly we have over here in the 0th row. Okay, now let's consider the first row. In first row, we have number 1 over here. This 1 has to be the exponent of the binomial. Then we have A positive B is raised to the power of 1. Anything raised to the power 1 is equal to the same stuff, that is A positive B. Okay, here this 1 is being as a coefficient of A over here. This 1 is being as a coefficient of B over here. Okay, now let's go to the next row. That is the second row. Second row means the exponent of the binomial has to be 2. Then we have A positive B is raised to the power of 2. Okay, now in this row, what we have to do is, so we have to multiply the two terms in the binomial, that is A and B. So let's see how many terms do we have in the second term over here. We have 3 terms, 1, 2, 1. So we have to multiply the two terms A and B. We have to write the product AB 3 times. That is AB, AB, and AB. Okay, now what I have to do is, I have to take this 1 as a coefficient of first AB. This 2 should be the coefficient of the second term. This 1 has to be the coefficient of the third term, AB. So if I take 1 as a coefficient for this AB, it's still 1AB, or simply we can write as AB. Now this 2 should be taken as a coefficient for this second AB. Even if I take this 1 as coefficient for this AB, still it's AB. Okay, now what sign do you have between A and B? It's positive. Since we have positive sign over here, all the terms in this expansion has to be positive. This is already positive. So let's take positive sign over here. It's positive sign over here. Okay, now, so what we have to do in the next step is, like what is the exponent of the binomial over here? We have 2. So the same 2 should be taken as exponent for A over here. And for this B, we have to take exponent 0. Okay, in the next term, what I have to do is I have to subtract a 1 from this 2. When I subtract 1 from this 2, it will become 1. That 1 should be taken as exponent for A. So I subtracted 1 from this exponent. At the same time, I have to add 1 to this exponent 0. 0 plus 1 is 1. That should be taken as a exponent of B. Okay, in the next step, what I have to do is I have to subtract 1 from this exponent, add 1 to the exponent. So initially, we started subtracting 1 from the exponent of A and adding 1 to the exponent of B. That we have to continue until the last term. So I subtracted 1 from it, I got 1. I added 1 to the exponent of B, I got 1. That I have written over here. Now, when I subtract 1 from the exponent of A over here, 1 minus 1 is 0. And when I add 1 to this exponent of B, that is 1 plus 1 will become 2. Then we get the value of B to the 0th power is just 1. That is, anything is raised to the power of 0 is 1. 1 times A square is still A square, positive 2 times. Whenever the exponent is 1, we don't mention, we can leave it. We can simply write it as 2AB positive Okay, here the value of a to the 0th power is just 1 because anything raised to the power 0 is 1. 1 times b square is b square. So the expansion of a positive b the whole square equals to a square positive 2ab positive b square. And here we have a question. What if I have negative sign instead of positive? So let me show you with that. Let me write a negative b the whole square. Again, the exponent of the binomial is 2. So now what I have to do is I have to multiply the two terms of the binomial over here, a and b. When you multiply a and b, please don't consider the negative sign over here. Just simply multiply the stuff what we have at the place of a, at the place of b. Don't consider negative sign. A times b is ab. So since the exponent is 2, we have to consider the second row of this Pascal's triangle. There are 3 terms. So we have to write ab 3 times. So that is ab and ab, then ab. Okay, now when I have to do the same process, that is whatever process I've done with the exponent. So the same thing I have to do over here. Even when I do, like I'll be getting a square, here 2ab, and I'll be getting b square. Okay, now what I have to do is I have to consider the negative sign over here. So whenever we have negative sign between the two terms of the binomial over here, in the expansion, I have to take positive and negative sign alternatively. That is always I have to take positive sign for the first term and negative sign for the second term and positive sign for the third term. So we have to do this not only for having exponent 2, even when you have exponent 3 or 4, whenever we have a negative sign, once we get the expansion, so we have to take positive and negative sign alternatively. Okay, now let me consider the expansion of the binomial, that is a positive b whole cube. Okay, so since the exponent of this binomial is 3, we have to go to the third row. So here, how many terms do we have in the third row? 4 terms, 1, 3, 3, 1. So the same thing, that is we have to multiply this a and b. What do I get? So ab, again ab, I have to write ab 4 times. Okay, now this 1 should be taken as a coefficient for the first ab. Even if I take 1 ab, it's still ab. Now this 3 should be taken as coefficient for the second term. This 3 should be taken as a coefficient for the third term. This 1 should be taken as a coefficient for the last term. Then we get 3ab, 3ab. This is 1ab. Since we have positive sign over here, everything should be positive. So we have to write positive, positive, positive. Okay, since the exponent of the binomial is 3, so we have to take the same exponent for a over here, and for b we have to take 0. Now we have to do the subtraction and addition process in the exponent. That is, subtract 1 from the exponent of a, add 1 to the exponent of b. When I subtract 1 from the exponent of a, it will become 2. When I add exponent 1 to this exponent of b, that is, when I add 1 to 0, it will become 1. Now again, subtract 1 from this exponent and add 1 to this exponent, then I'm getting 1. So here 2. Again, when I subtract 1 from this exponent, it will become 0. When I add 1 to this exponent, it will become 3. So now b to the 0th power is 1. 1 times a cube is a cube, positive 3a square. B to the first power can be written as b, positive 3. A to the first power can be written as a, b square, positive. So a to the 0th power is just 1. 1 times b cube is b cube. Now let's consider the same expansion with the negative sign over here. That is a negative b the whole cube. So when I try to get expansion for this one, so whatever result I'm getting for a positive the whole cube, the same terms I'm going to write. So the only change what I have to do is I have to take positive or negative sign alternatively. So that is I have to start the first term with positive sign a cube. The next term it has to be negative 3a square b. The next term positive. The next term has to be negative. So this is the expansion for a negative b the whole cube. So like using Pascal triangle, even we can get expansion for a positive b whole to the 4th power, or a negative b whole to the 4th power, 5th power. So like we don't have to remember the algebraic identities always. So whatever stuff I have done over here, using the stuff we can get the expansion for any binomial. Okay, now based on the stuff we have discussed, we can get expansion of some of the different binomials instead of just having a and b. Let's consider some of the different stuff. Okay, now let's go to an example. Here we have a binomial with the exponent 5. Since the exponent of the binomial is 5, we have to go to the 5th row in the Pascal's triangle. So now let's count the number of terms in the 5th row over here. We have 1, 2, 3, 4, 5, 6. There are 6 terms. So now what I have to do is I have to get the product of the 2 terms in the binomial, that is 2x and 3y. So let me write the products over here. 2x and 3y. So again, I have to write the same product, that is 2x, 3y. So 2x, 3y, 2x, 3y. So 1, 2, 3, 4, 2x, 3y, and 2x, 3y. So I have gotten the product of the 2 terms in the binomial. for 6 times because we have 6 terms in the fifth row of this Pascal triangle. So the first term in the fifth row, this one should be taken as a coefficient for the first term over here. Even if I take one as a quotient, it's still the same. Okay, now let's consider the second of this phi. This phi should be taken as a coefficient for the second term over here. And for the third term and fourth term, I have to take 10 as a coefficient. So let me write 10 and here 10. And for this one, again, we have the coefficient phi. And for the last term, the coefficient is 1, that we don't have to write it. Since we have positive sign over here, all the terms in the expression have to be positive. So here positive, 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 positive. Okay, now let's consider the exponent of the given binomial, that is phi. So always this exponent phi should be taken as exponent for the first term over here. I mean, for this one. So now for this one, what I have to do is always we have to take the exponent 0. Okay, so in the next term, what I have to do is I have to subtract 1 from this phi and add 1 to this 0. Then we'll be getting 4, 1. Then again, I have to subtract 1 from this 4, add 1 to this 1. Then we get 3, 2, subtract 1 from this 3, add 1 to this 2. Then we get 2, 3, subtract 1 from this 2. Then we get 1. When I add 1 to this 3, I'm getting 4. Now subtract 1 from this 1, I'm getting 0. Add 1 to this 4, I'm getting 5. Okay, now let's do the evaluation. So when 2x is raised to the fifth power equals to what? So whenever actually 2 and x are multiplied and we have the common exponent phi. So whenever two terms are multiplied and we have the common exponent, what we can do is we can distribute this exponent to each term. Then we get 2 to the fifth power and x to the fifth power. Once we distribute this exponent to each term and multiply the results, because the 2 and x are multiplied. So 2 raised to the fifth power equals to 32 times x to the fifth power. So 2x raised to the fifth power is 32. Let me write the stuff for 32, x to the fifth power. So when 3y raised to the power 0 equals to 1, positive 5 times. Now we have to evaluate this 2x to the fourth power. So when since 2 and x are multiplied, this 4 can be distributed to this 2 and x. So when I distribute this 4 to this 2 to the fourth power, 2 to the fourth power is 16. And when we distribute this exponent 4 to this x, it will be x to the fourth power. 3y raised to the first power is just 3y, positive 10 times. Now when I evaluate this one 2x to the raised to the third power, so like what I've done for this 2x to the fifth power, 2x to the fourth power, the same thing I have to do for this one. That is 2 raised to the power 3 is 8. X raised to the power 3 is x cubed. So now 3 raised to the power 2 is 9 and y square, positive 10 times. When I evaluate this one, I'm getting 4x square. And when I evaluate this one, 3 raised to the power of 3 is 27, y raised to the power 3, that is y cubed. And now positive 5 times 2x raised to the power 1 is just 2x. So when I distribute this exponent 4, this 3, it will be 3 to the fourth power, which is 81. When I distribute this exponent 4 to this y, it will be y to the fourth power. And the value of this 2x raised to the power 0 is just 1. When I distribute this exponent 5 to the base 3, 3 to the fifth power is 243. Then when I distribute this exponent 5 to this y, it will be y to the fifth power. Okay, now let's do some simplification. So when I multiply this 32x to the fifth power by 1, it's still the same, 32x to the fifth power. And now what I have to do is I have to multiply this 5, 16 and 3. Okay, now let me use the calculator. 5 times 16 is 80. 80 times 3 is 240. So positive 240 x to the fourth power, y positive. Now I have to multiply this 10, 8 and 9. When I multiply this 8 and 9, I'm getting 72. 72 times 10 is 720 x to the third power, y square. Okay, now let's multiply this 10, 4 and 27. 10 times 4 is 40. Now I have to multiply 40 by 27. I'm getting 1080 x square y cube. Let me write the stuff over here. Okay, now what I have to do is I have to multiply this 5, 2 and 81. 5 times 2 is 10. 10 times 81 is 810 x y to the fourth power. Let me write the stuff over here. Now I have to multiply this 1 and 243, that is 243 y to the fifth power. So now I got the expansion of the binomial, that is 2x positive 3y raised to the fifth power. So in case, what if I have negative sign over here, that is 2x negative 3y whole to the fifth power. So all the process what I've done so far is the same. So the only thing what I have to do is I have to change, I mean I have to take the signs alternatively, that is positive and negative. That is I have to start the first term with positive sign, that I'm getting that is 32x to the fifth power. Then for the next term, for the second term, I have to take a negative sign, that is negative 240x to the fourth power times y. For the third term, positive, because positive, negative, positive, positive, negative, already start. We always have to start with the positive sign. 720 x to the third power y square. For the next term, I have to take negative 1080 x square y cube. The next term, I have to take positive 810 x y to the fourth power. So the next term, I have to take negative, that is negative 243 y to the fifth power. Okay, I think everyone can understand this stuff. Thank you.